On January 27, 1967, three astronauts walked across a metal catwalk high above Launch Complex 34, heading toward their command module for a routine checkout. This test was designed to be a standard procedure, yet it would end in the worst tragedy the American space program had experienced up to that point. How did a highly controlled, supposedly safe environment turn into an inescapable trap? The fire emerged from a convergence of specific technical, procedural, and organizational hazards, all waiting for a spark. The crew of the Apollo 1 mission consisted of Ed White, Gus Grissom, and Roger Chaffee. Their objective was to conduct the first crewed test of the Block 1 command module, a spacecraft that had arrived at the Cape with dozens of unresolved engineering issues. The schedule for January 27th called for a plugs-out test. This involved strapping the astronauts in and simulating a full launch countdown while the capsule was detached from ground cables, forcing it to run entirely on its own internal power. Because the Saturn IB rocket sitting underneath the capsule wasn't loaded with any volatile fuel or cryogenics, NASA made a fatal administrative assumption. The agency officially classified the test as non-hazardous. That classification dictated the day's safety protocols. Because there was supposedly no danger, no emergency escape plans were activated, no specialized fire suppression equipment was prepared, and no medical rescue teams were stationed at the launch pad. The crew was bolted into a highly pressurized machine, isolated at the top of the launch structure, with no specialized safety teams on standby. Once the astronauts were sealed inside, the environmental control system pumped the cabin full of 100% pure oxygen, pressurized to 16.7 pounds per square inch, an internal pressure slightly higher than the atmosphere at sea level. In a pure oxygen environment, materials that might only smolder in normal air will burn violently. Despite this, the cabin contained up to 70 pounds of flammable non-metallic materials, including 34 square feet of Velcro and extensive nylon netting. Hidden beneath the command pilot's couch lay an ignition hazard, silver-plated copper wiring that had been stripped of its Teflon insulation by a repeatedly opened access door. This frayed wiring ran directly beside a plumbing line filled with a combustible ethylene glycol and water cooling mixture. At 6:31 p.m., sensors recorded a sudden voltage spike. An electrical arc ignited the coolant mixture, and within seconds, a fire surged through the pure oxygen atmosphere. The Block I hatch used an inward-opening plug door, larger than its frame, relying on pressure to wedge it shut. Venting the cabin to open it took 90 seconds. But intense heat spiked the pressure to 29 psi, cementing the hatch with immense force. The engineering mechanism designed to keep the astronauts safely sealed inside the vacuum of space trapped them inside during the ground fire. The crew did not survive. NASA immediately grounded the entire lunar program and convened the Apollo 204 Review Board to dismantle the spacecraft and determine the cause. Investigators disassembled Command Module 012 piece by piece, sifting through the scorched interior to map the fire's spread and locate the precise point of ignition. What they documented was a pattern of compromised hardware. They found sloppy workmanship, exposed and degraded wiring, and poorly inspected components scattered throughout the vehicle. To prove how vulnerable the system was, investigators brought in a pristine twin spacecraft, CM-014. By dismantling it side by side with the damaged capsule, they could trace the exact routing of the faulty wires and uncover the design's blind spots. The board concluded that NASA and its contractors had miscalculated the lethal dynamics of a high-pressure, pure oxygen environment. The disaster was a systemic failure. The board's findings forced a total redesign, prioritizing fire safety in the Block 2 vehicles with extensive flammability testing. The first major fix was the atmosphere itself, replacing the pure oxygen environment with a safer sea-level mixture of 60% oxygen and 40% nitrogen. The interior materials were overhauled. Engineers removed the flammable nylon and excessive Velcro, replacing them with self-extinguishing materials like Teflon-coated beta cloth. The most crucial mechanical change was the exit. The inward-opening club door was discarded, replaced by a unified explosive hatch. Driven by a pressurized nitrogen cartridge, it rapidly pushed outward and could be opened in less than 10 seconds. These engineering changes addressed the hazards that had made the Block I spacecraft vulnerable, creating a vehicle capable of surviving the journey to deep space. Gus Grissom, Ed White, and Roger Chaffee never got to fly their mission and were laid to rest with full military honors. Their loss forced a shift toward rigorous safety protocols and mechanical reliability, establishing the standards necessary for a successful moon landing. Which of the Apollo 1 safety redesigns was the most critical for the success of the lunar landings? Let us know in the comments below. If you enjoyed this video, please like and subscribe to Cosmora HQ for more evidence-led space documentaries.